Right. Good morning, everyone, and welcome to the session. So, in today's session, I'm going to talk about the database handling part, which is focus in the backend, the MySQL, database and the related commands that we are going to discuss. But before we continue, I would like to know how many of you are already familiar with MySQL. Can you please raise your hands whether you are already familiar? Yeah, keep on raising your hands because I want everybody to. Okay, we have half of the class already familiar. Is there anyone who is not familiar? Prasad, Hasanti, Sama, Kalaivani. Okay, I'm assuming everybody is okay, very familiar. So I can quickly finish that part. Okay, thanks everyone. So let me know, maybe we can focus on the assessment part then. The first one is let's basically discuss the MySQL basic part, which I think hope already you know. Um, Now, when you are working with the web application, especially when you want to handle data and when you want to keep on transactional data, what I mean here, transactional means the things might change very frequently. Of course, we better have a database. Now, if you look at the newest trend, now we can select relational databases as well as NoSQL databases, especially depend on your requirement. If your data has a structure, a fixed structure which will not change, but then you have a lot of transactional data, still I think the people are preferred to work with relational databases, and that's what we are going to discuss under MySQL. So in this example, you see a simple table, database in relational database manner, we see it as a handling a set of related database tables, and then you have a structure. So you will have, if you create a database in MySQL, you will have a set of tables, and then you can, each table, you have a set of records and, rows. And then you have a set of fields. For example, in this example, we have a table on authors of the books. So we have fields like author, title, type, and year. Right. Now, the creating database can be done in multiple ways. One is you can use a graphical interface which provides once you install. For example, if you install SAMP environment where you will have different tools or graphical tools you can use. For example, if you use MySQL has its own graphical database creation tools. But I think those who are going to work in the industry, you always prefer to use command line interface, which I also want to stress here, because that could be easier for you to work with, right, professionally. And you can write a lot of scripts where you can automate most of the tasks. So assuming that we have a SAMP, here I have list the commands. By the way, how many of you are already familiar with SAMP? What about Asanka, Prasad, Shifani? Right. Okay. So simply, like in the command line interface, you can go to SAM folder, and usually you go to bin folder. And assuming that you are going to access it as a root, we can say MySQL minus u root and minus p for providing a password. Then the next thing is we should also know about the basic MySQL commands. Here are the basic MySQL commands that you can, when you work with, MySQL database. So depend on your requirements, we will use, combining multiples of these commands together to make the database. So if we start with the creating database, so simply the main thing is you first start with the creating a database and the using it, and then you create a set of tables inside. When you're creating set of tables inside, we have to define the fields, a field name and the data type, and also any other properties that you want to have. And at the end, we will use what we call the engine. In this particular case, I put InnoDB. How many are familiar with the engines available in MySQL? For example, InnoDB is a storage engine which supports transactions, which means commit and rollback operations, especially when you want to write transactional database queries. Right. Then the data types, you already know. Selection of a data type is very important, and you have to make informed choice of what data types that you are going to use, because it depends especially your requirement, and then it affects the storage, and then also the query execution time. So having said that, I have a small question for you guys. So what is the difference between the character and variable character, or char and varchar? Yes, maybe you can write your answer in the chat, or you can just unmute and then let me know. Character and variable character, char and varchar. When are you going to use which?
And like the sentences, we can use watch and characters on one symbol and the number of bytes that allocated is more.
Okay, Prasanga, now for example, if I were to store a name of a person, which one I should choose? Is it character or variable character?
Uh, Variable characters good.
Would be good, right? Because
Yeah,
we never know how many characters are used. But let's say it's a telephone number, which one you are going to prefer?
is that exactly that number of bytes we can use that jar or something?
Exactly. So assuming that if you, let's say you are going to have only 10 characters, then maybe you go for,
Character.
because it depends on the size of the data. So you can look at the data set size as well. The character has a fixed set of, bytes are allocated. For example, if it is hello, it says exactly uses 5 bytes, and then 57 goodbye uses 57 bytes. But if you allocate watch 100, but if you say goodbye, it uses only 7. So that is rough estimate, and actual value is slightly changed from this, but I don't want to go into that detail. But remember why we have to use them, right? Now, similarly, there are other data types as well, which you need to think about. So for example, especially when you want to store, numbers, the ranges, remember, is very, very important. For example, if you work on signed numbers, which means if you want to handle both the positive and negative numbers, you can use signed. But then If you're using, let's say, only the positive one, then you can go for unsigned. Now, for example, if you select data type like int, for example, or let's say tiny int, so if you choose data type as tiny int and number of bytes you allocated for the data size is 1 byte, and the range of that numbers that you can represent is goes from minus 128 to plus 127. Then if you say unsigned, which indicates that you are going to store only positive values, then it goes from 0 to 255. So depend on what the range of numbers that you are going to store, then you can define what data type that you would like to use there, right? For example, tiny int will use only 1 byte, whereas if you say int, that is a common use, will allocate 4 bytes, right? Then there are different date and times, and then it has their format as well. For example, date and time will support both time and date format. Date will only support the date. Timestamp only supports timestamp. The date and the time both, and the time will be only time. And year will indicate only 4 letters. Okay, now when you're defining columns, especially let's say you have an ID which you want to automatically increment, we can use auto increment attribute, which will automatically attribute, which increase the value of that ID, right? So which is kind of a useful for you, especially when you work with, let's say, a unique ID that you want to uniquely change the values, right? And then auto increment would be the way to work with those. Then you can also use other things. Now, for example, here we have over to table classics. We can say add ID, int, unsigned int. We are going to use integer data type. And we are going to use only positive range of this, starting from 0, we say unsigned. And then we say not null, which indicates that the null values are not allowed. And then we say auto increment, which indicate that it will automatically increase. And finally, it says it's the key attributes. That means the primary key. So you can see, you can also add this when you're creating a table. So in the table definition, you can have it. And the next one is you can also add as a separately, right? Both ways are possible. So here are the commands for creating data to the table. And then here are some examples where we can actually change. Right, now since you are very familiar with this, right, so I just want you to create this table, right? Take about like 10-15 minutes. I want you to come up with a simple SQL script for generation of table, and also creating a table inside that database, and then you fill with this data. Shall we start? Correct. Yeah, discussed the answer already. I got the answer from Prasanth. Thanks for sharing. And then a few things that I would like to discuss. First of all, I actually wrote it as a script file, but I think, yeah, if you just create the table, that's fine. Couple of things I want to note is use of the data types as well as the sizes I have used. So again, this is how I implemented, but you can decide different numbers. That's perfectly all right. Author title, you can use varchar, and then the size you can decide. The type is again the same. The type is also you can decide the number of characters you want to limit. In my case, it's 16, but the year it's a fixed one. So I think that definitely you should use char data type with the number 4. ID, of course, you can decide again different data type. In my case, it's int. Unsigned, because ID I'm assuming that I'm going to use only integer values, and I'm going to keep it as a primary key, so it should not be null, and it should automatically increment it. And also I decided the primary key as the ID. And when I want to insert the data points, I have done one at a time. Actually, you can use in a single run. So I included only author, title, type, and year only, because ID, I want system to be generated, right? So I'm not going to enter the ID value here. So only the author, title, type, and year values, right? And when I execute this, right, this is what I have, right? So if I say show tables, I can see I have classics. Describe classics will give us the structure, and this is how I structure the database. Then of course, if you look at the data, select all from classics. Yeah, here are the data points that I have installed. The last two lines you can forget, they are, I mean, later on we have added, but definitely the first 5 data points I want you to include here. Right. Okay then. So the basic ones you already know. So I'm going back to the slide again, right? And adding data also we have discussed, adding auto increment also we have discussed. Other commands, again, you could try this, not necessarily change it. Now in this here, we discussed a couple of alternate commands that could be used for renaming your tables, renaming, your, data types of the column, or you can even adding some columns here. Similarly, renaming a column is example, order table classics, change type, and then we change category to varchar 16. If you want to remove some column, we can use all the table classics. You can drop and you can remove pages, for example. Then you can delete table. So in this particular case, you create a table, disposable, and then you describe it, drop it, and then you look at it. So again, just simple commands, you may have already done this. Right. Now, having a unique key for each row is important. In this particular case, we are adding a new attribute called ISBN with the size of 13 characters. And we update all the records. And then we add it as a primary key. So again, you could try this. So I'm not going to spend time on that. And when you want to create the primary key, when you create the table, that's direct. So you can say ISBN in this particular case, we created with the 13 characters, and then we decided as a primary key. Right, now, simple table searches. So simple tables like what we have just inserted, you don't have any problem of searching data. But when your data grows up, sometimes your files might take a considerable time when you're searching particular piece of information. To make it efficient, we can define what we call indexes. So we can talk about regular index, primary key, and then full text indexes. So the decisions that you want to make here when you're creating indexes is which columns you need to require the index. Because if you have like, for example, you might think, okay, maybe I will define everything will be as index columns. Of course, it will take time. So searching will be efficient, but the problem is whenever you write data to a database, every time you write new, you have to update the index. So there's always pros and cons of this. So you have to be very careful how do you decide on the index field. So here is how we may actually create indexes. We can use indexing authors, titles, categories, and years. And then when you say describe, you will see it's indexed. So you can see now the final updated file where we create the table classics with author, title, category, and year. And we have used ISBN as a character 13. And by defining several attributes as indexes. Okay. So those who have created the databases, I want you to make change, reflect in your table. Discuss from the difference we have discussed from the previous one is, in previous one, we have a ID, which is automatically incremented, but we have changes to ISBN here, where we keep 13 characters. Also, we introduce set of indexes where this is very useful in case when we want to, efficiently extract, data from the table. Now, then the next thing that I would like to discuss, when you have multiple keys or multiple tables, we want to combine data or tables using what we call the foreign keys, right? So when we talk about foreign key, so that could be a set of fields or field which could be connected the other table's primary key. Now in this example, you see we have persons and order table. And you can see instead of after the primary key on the orders table, you will see we will define foreign key and we references to the person. We references to the person. So now one thing that you have to think about is what might happen when you define a foreign key. what if you delete something, right? How it affects the other person, right? So that's what I want you to think about it. So having said that, we have our previous one. Now I want you to create another table where you keep track of person information, and also, like, let's say, a loan information, right? So just to explain, like, what I want you to think about is, like, right now we have a table classics, which we have author, title, category, and year. Create another table in the same database, let's say users, with uh, a name and other information that of your choice, and then what books a person may borrow from, right? So what you could do is you can create two tables, where one is you can create a user or customer table, where you can have some information, where you can keep the reference information as well, and another table where you will have a, a reference from your classics to the users, right? Shall we start that? Let me repeat. Now that we have a classics table where we have books information, I want to create another table, which, let's say, a customer, right? Which I will store data about the users of this, let's say, these the books. And another table that I need, you want to make the connection. Right now, what we have is we have classic table. So I want you to create uh, three tables. Right now we have classics table. So I want you to create another two tables which actually combine these two tables together. So one is classics that we have already created. And then the primary key is ISBN. So I will list ISBN. That is the primary key. So customer, let me say customer ID. So here I have to have ISBN and customer ID. Create a table structure like this and design the foreign key accordingly. Now, at the same time, think about what should happen if you delete something. Now, when you have foreign key references, we have to think about what should happen when you delete something, right? So, for example, what should happen if you remove a record in a classics table, or what should happen if you remove a record in a customer table, or if you update something. So what should happen? Right. There's a very important questions raised, Prasanna, about the previous one. So I will quickly go back to the previous one where we have index. Now I told you like indexes are created to efficiently run or improve the query performance. Now earlier we said author is maximum is 128 characters, but that is too much when you want to like work on, especially when you're creating index. So here the author 20 means when you're creating index, we will say, okay, consider only the first 20 characters for first 20 characters of each value, right? But so if you have a too many, too much, characters, like originally we have created 128 characters here, but that is too much, right? So we know to limit the size of the index to improve the performance, right? So this 20 is, somebody has to decide that 20. So meaning the 20 here is we assume that the first 20 characters are enough for you to efficient searching. So I hope, Prasanga, you got the answer.
Yes, doctor. Thank you, doctor.
Okay, so what we were trying to do is looking at the references section. So under this, what mainly I want to focus is on creating references, especially when you have multiple tables. So I asked you to create two tables and put up some values. And then I asked you to think about like what should happen when you remove particular records in these two tables. To explain what I actually referred here is what should happen when you remove something in the two tables. So in this particular case, I have only two tables I have created, and I use simply ID, but in your case, I have originally asked you to create three tables. Just talk about what should happen now like this. Right now, if you look at the two tables, so you will see that when you remove a row in a customer table, let's say Mary Smith, we are going to remove. So we have allocated book number 3. Now what should happen, right? The right now, if you just look at in the customer table, you might not see any imports of that. You can just simply remove that without affecting anything. But sometimes when you remove Mary Smith, whatever the related item also you need to remove. So that means when you are creating references, you have to also think about what should happen when you update the record and when you delete the record, right? So generally, the two things that we normally use is we can either ask to cascading or the updating it in the other table, or you can remove the instance. Now, for example, let's say we have a book ID number 3, and we will remove the book ID or book from the system. So which means what should happen to Mary Smith? Should we remove Mary Smith as well? Or should we make it null to book ID? Or should we assign something else? So this is the kind of question I want you to think about, especially when you are making multiple tables together, when you are referencing the other table. So the ideally what I expect is when you're defining or when you're creating foreign key constraints, when you're making an update or when you delete, you have to accordingly make the instruction, whether you are going to cascade that update or whether you are going to remove it. Or whether you are going to set it to null, right? Keep that in mind. So let me go back to the slides again. Let me finish MySQL today, the last couple of slides, and then we can start PHP from next session. Right. Now that we have used of foreign keys, and I told you like the think about like what should happen when you make it update. The other things are querying MySQL. I'm not going to talk about in detail because you have already done this. Right, but couple of things, we can use aggregate functions, we can use distinct functions, especially SQL may contain duplicate values. We may have to use distinct keyword to remove any duplicates. And then you can also, narrow down the number of queries. For example, couple of things you can do. One thing is never in production system, we should never use asterisk or selecting everyone or select all operation because of the inefficiency of the queries. So maybe you have to particularly select particular fields to avoid that. Or maybe you can use limit to say that how many records that you are going to access it. Right. Then the limiting is very important. As I discussed this early, we never use select all because it will more efficient. And if you are in a cloud architecture, this may cost a lot of resources. So make sure that you use limit appropriately and given the range. Right. And then again, updating, you can use update and set, changing the values. Order by, when you want to sort the order based on columns or set of columns. The group by, when you want to use aggregate. Right. Now, when you want to join the tables, especially now once you create several tables together, joining you can use in multiple ways. One is you can use a single select where you can use where close, where you indicate what attributes that could be used to make that relation. Or if you want to join the tables automatically, we can use natural join, or you can use join on condition. So that's normally you will use. And you can also, to improve the readability of your queries, you can always rename your column, and then accordingly you can use them when you write the queries. Right. I think that's all what I have for MySQL. The small exercise that I'm going to discuss in the next session would be how do you handle the deletes and updates when you use a foreign key. So, work on this problem, and especially when you remove a data point, what should happen to the other table, right? So think about that, and we can have a small discussion before we start the PHP session next week. So the next week, then what we are going to aiming at, we will start with the PHP. That's our last part of uh, the session. Okay, thank you. Then we'll stop for today and meet you next week. I will post the now that we have done the database part of it. So this week I will have a small assignment on our educational application that we are going to create. I told you like we are going to do it in one single application, and we'll take different parts of it. So that information I'll be posted together with a small assignment on database application. Okay, thank you then. Hope to see you guys next week then.
Okay,